Hello. For these two problems, from 1985 to 2009, the number B of federally insured banks could be approximated by this equation where T is the years and T sub 0 is 1985. So each time you're given a year, you need to subtract 1985 to find the number of years after that. How many federally insured banks were there in 1990? So we need to find T. In 1990, we need to know how many years that's been since 1985, which is 5 years. So then you plug 5 into the equation for T. And you'll get 12,127 banks. The slope of the graph of B is just the part that is attached to your variable. So it's the negative 323.4. To interpret the slope, remember it's change in y, and y is the number of banks. And x is the number of years after 1985. Each additional year, the number of banks decreases by 323. Because it's negative, it would be one of these three that are decreasing. And it's each year, because the number of years. So each year, it decreases by 323.4 banks. So that's what the slope tells you. As x changes, how does y change? Find the y-intercept of the graph. The y-intercept is your B. And in this case, it's the 13,744. The y-intercept is when x is 0. Because if you plug 0 into this equation, then you just have the y-intercept. Well, when x is 0, or t, that's 1985. So in 1985, there was 13,744 banks. So let's see, the y-intercept is the minimum number of banks. The y-intercept is the number of banks. The y-intercept is the number of banks in 1985. Because 1985 was times 0. So that's why it's this one, at times 0. T0 corresponds to 1985. This second problem, where they're giving us the equation, let f of x be the height of a maple tree in inches and x be the number of years since 2000. A linear model, and they give you the equation. To the nearest inch, estimate the height of the maple tree in 2016. So then again, you got to find the number of years since, in this case, 2000. And we're using x. So x equals 2016 minus 2000, or 16. So then we just plug 16 into the equation. I think the biggest thing is make sure you're using the equation and not trying to estimate it from the graph. And when you plug that in and round to the nearest inch, you'll get 235. It's 0.2222, but we're rounding to the nearest inch, so 235. Part B, use the equation to find the year. So in this case, we're finding the year when the tree will be 248 inches tall. The y value is inches, so we plug in 248 for y and solve for x. Subtract the 84. And never round until the end. And then divide by the 9.44. You always do the opposite. This was multiplying, so we divided. Now we're looking for the year. We're getting 17.3. And remember, that's years since 2000. So we have to add that 2000. So it would be in 2017.